magnetic field will magnetize any secondary mass in close enough proximity to the primary mass, creating the magnetic field, no matter what elemental components the secondary mass is comprised of. There are two distinct directional flows of a magnetic field on a secondary mass, south magnetic oriented and north magnetic oriented. I will explain the importance of the difference in the effects of these two opposing magnetic orientations later in this segment. Any secondary mass, no matter what element or combination of elements the secondary mass is comprised of, such as wood, plastic, metal, or any element, will succumb to the effects of a magnetic field created by a primary mass. It is just that the effects are not easily seen in elements that are non-magnetic, or in elements that cannot be permanently magnetized, like wood or plastic. In other words, the secondary mass is forced to receive its strong force energy from the universal static grid in a particular direction, south to north flow, rather than spherically radial along its circumference and length like it normally does. Or, in other words, the electron functions of the secondary mass are forced to become temporarily aligned in a south to north flow, because the magnetic field of the primary mass forces this to happen. Here is an example. The round magnet shown here is the primary magnetized mass. The wooden tabletop is a secondary non-magnetic mass, and the metal screw is an additional secondary mass to show that the wood is indeed become temporarily magnetized. The magnet will move the metal screw right through the tabletop. This is because the magnet is temporarily forcing the direction of electron functions of the atoms of the wooden tabletop, and the magnetic field of the magnet happens to be strong enough to also affect or align the electron functions of the metal screw. However, iron, or the metal screw, is one of the few elements which happen to have the correct number of protons and the correct choreographed sequential electron functions to be ready, willing, and able to accept and even retain magnetic or south to north aligned electron functions. This is why iron will physically attract to and bond with the magnetic field of a primary mass. The non-magnetic elements are not quite so ready, willing, or able to be magnetized because they do not have the correct number of protons and correct choreographed electron functions to become permanently magnetized, and can only be temporarily magnetized. This is why other elements are considered to be non-magnetic and will not physically attract or bond with a magnet.